Good evening. Hello, everyone. A warm good evening and a welcome to the resource person, all the participants and the advisors team of ThickNess Learning Community. We, ThickNess Learning Community, are happy to have you here for the international webinar on an interactive intro to AI ML. We, ThickNess Learning Community, is an online startup zeroing in on sharing the knowledge through collaborative studies by organizing the expertise in professional talk, inspiring and motivating young minds towards entrepreneurial leadership vision through various programs, and accelerating women empowerment that commits to scale up the quality of their life. Our upcoming webinars are Green Chemistry, Educational Article Review 2.0, along with many international graduate courses like IELTS, Functional Mathematics, 3D Printing, Basic Electronics, and etc. And now, I would like to introduce our young and dynamic resource person, Mr. Logesh Venkatrajulu. Mr. Logesh is a software application architect with 15 years of experience in enterprise application and solution architecture. He has worked on Java JE implementation for large enterprises in Germany and US. He is now a Salesforce architect leading technical implementation in government sector in the state of New York, US. He is also the founder of Kaneeni.com, which was acquired by the US-based Human LLC earlier this year. He has been passionate about learning and teaching technology throughout his career. He believes in making tech easy to understand through stories and scenarios. He has been embarking on the path of AI and ML for the last 3 years with special focus on ML implementation and frameworks. With this note, I would like to welcome our resource person, Mr. Logesh Venkatrajulu. Welcome, sir.
Thanks, Kritik. Thank you.
And once again, I would like to welcome all the members to ThickNess Learning Community to have a great eve with AI and ML. Over to the resource person.
Thanks again, Kritik. Thanks for making this happen to the entire team of ThickNess Learning Community. I'm very happy to do this. All right. Good evening, everybody. Kritik gave the introduction already. I'm Logesh. So today's topic would be an introduction to AI and ML. So without taking much time, I will switch to the agenda right away. All right. There we go. Right. So what we're going to talk about today is artificial intelligence and machine learning. The agenda is like we'll start with a basic introduction of the terminology and the concept of AI and ML. And then we will go deep into the different types of machine learning techniques. We'll do a simple exercise to understand that better. And later then we'll move on to some of the learning methods with a special focus on deep learning. And we'll also take a tangential look at data science and how everything, all of this put together and works together. And we'll move on to some real world examples, some of the things that you're already using, some of the things that you are aware of and that you're not aware of. And after that, we'll move on to some of the tools, frameworks, the software ecosystem of how machine learning works, and then some of the latest trends in the area, and what are all the different certification opportunities, learning opportunities for someone who's starting on ML right from scratch. And we'll end by talking briefly about what we do at Kaneeni, which is now a human-based company. We'll also go through the team members of human if time permits. All right, so we'll get started. Right, a small little intro video. Right, we can get started now. Right, so artificial intelligence, as you all know, it's been the buzzword for quite some time now, and you'll obviously find a lot of definitions for artificial intelligence. Now, right here, I'm just going for some of the simplest ones, or some of the very initial ones of artificial intelligence. The concept itself goes back to the 1950s. The definition itself also goes back to the 1950s. It is not it's not something that was recently conceived. So to go to the definition itself, we'll start by splitting the word artificial and intelligence. Right, we'll focus on the word intelligence first. The textbook definition of intelligence goes like this: the ability to learn, understand, and use the knowledge to take decisions with reasoning. Right, there are several keywords there: learn, knowledge, decisions, even reasonings. So, um, you know, that's intelligence. Now, add the word artificial to it. Now, that will be the ability of the machines to learn, understand, and use the knowledge. Basically, when we say that, it will learn from the data and the environment that it is exposed to. It could be a program, it could be algorithm, anything. But when it starts to learn from the exposure that it attains, that's when it starts to exhibit artificial intelligence. That's when it starts to exhibit intelligence. And just that, because it's being exhibited by a machine, it's called as artificial intelligence. Now, another simplistic definition: it's the ability of the machines that can perform tasks that are characteristic of human intelligence, right? When we talk about human intelligence, of course, it's various threads, and I've just listed some of the initial ones, right? I mean, not some of the basic ones: planning, recognition, learning, decision making, and problem solving. In a way, these are all very abstract concepts when you look at it from the AI perspective, because there is so many things that is involved behind this concept of behind the strides of planning, recognition, and learning. So how can a machine do that? How can we enable a machine do that? That's what this is going to be all about. And in the further slides, we're going to dive deep into those. And the field itself, the last definition, the field of artificial intelligence itself is kind of defined as the science and the engineering of making intelligent machines, or making machines intelligent. Like, that's for the field of study. Right. So that's like the basic um, definition. We'll go further into machine learning. All right, machine learning. Again, another buzzword. It's no more, you know, it's no more a textbook concept. It's all in implementation for quite some time now, and it's kind of, you know, uh, is reaching it. It's going on a trajectory where it's going to have an exponential growth. The whole concept of machine learning. Right. Let me make this full screen just for a second. Give me 1 second. I'll make this full screen. Well, unfortunately, I just can't make it. All right. Yeah. Got it. Right. So the way, again, another simplistic view of the term itself, the machine learning. Um, what I try to generally do is add the word "is" in between machine and learning. Basically, just explaining the concept. What's happening here is the machine is learning. That's all it is. And what do we mean by that? What do we mean by a machine is learning? So we're going to go through that. So definition wise, it's a way of training your algorithm or your program. It could be a software program or an algorithm that to learn and improve and act without explicitly programming it. The word "without explicitly programming it" is the key here. So you're not programming for every possible outcomes or every possible scenarios a program may be exposed to, right? It has to grow dynamically, and it has to grow dynamically based on the data or based on what it experiences. And we will see how. Right, another simplistic view, again, for machine learning. We're all familiar with the concept of input, process, and output, right? Throughout our study, in whatever field it is, right? The concept of an input, a processing, and output. The key here is the interesting area here is the processing part, and especially in machine learning, right? So in the world of machine learning, that piece of processing is called as a model. It's a trained program or a trained algorithm that acts instinctively based on what it's exposed to. It's called a model, and it's basically a representation or a formula for the process. You're basically defining a formula to convert your inputs to your outputs. That's all pretty much this is. The formula could be very simple, or it could be really a complex set of instructions to make it happen. That's pretty much what is a definition for machine learning. And it's basically it's a way of achieving artificial intelligence. Sometimes the term itself is confused as to it's equated to AI, but it cannot be directly equated, and we'll see why in the next slide. All right. So the title there says AI is not equal to ML. It's not directly equatable. It's actually a subset of AI. ML is a subset of AI, and ML is a means to achieve AI, means to achieve the end goal. Now we'll see all of this using a simple example, right? We're going to see a lot of examples, and the focus will be more to make you get involved with these examples as we do exercises. Right, the first example that we're going to see today is traditional like let's assume a modern day smart television that people have these days, right? We'll have three scenarios attached to it, attached to this television use case, and then we'll talk and we'll define AI and AI plus ML with that, right? Assume that the first scenario is like you have a television set, you have a remote, you just hit a button, it opens up, it tunes into a channel, and you start watching it. Very simple, right? So what's happening is it's very simple programming. You hit a button, the button sends out a command, the television receives the command, it knows what it needs to do. It's told, and it's programmed to do that, and it does that. Very simple. Now take a second scenario here. You can sometimes, with the modern day remotes and stuff, you can send voice commands over to your TV. Hey, you know open Netflix, open this particular channel, or play sports, something like that, right? There is a lot of things involved in here. Your voice recognition, there is natural language processing, there is natural language understanding, and you're passing the communication back to the television. The television interprets it using those techniques, and then tunes into that channel. An artificial intelligence use case, because it is trying to understand what it is and trying to make a decision of it. But now, this does not have ML. You'll see why with the third use case. Suppose, imagine this particular scenario. You have a habit of watching, you know, a news channel at 7 p.m. let's say every day, and then let's say a sports channel at 8 p.m. every day. Let's say you do that over a period of time. Now, what if your television, understands that, captures that, stores that information? Like, hey, okay, this person watches this particular channel every day at 7 p.m. and watches sports at every day at 8 p.m. Now, let's say another day comes by, it's 7:10 p.m. and you're watching something else, right? What if suddenly it pops up on the television that says, "Hey, it's 7. Do you want to watch this, or you want to watch the news channel?" You know, so that's an example of machine learning in it. The television has learned your habits based on what you have been doing. It has seen a pattern in what you're doing, and now it's prompting you to do something. It's acting on that knowledge and it's acting on the decision. This has AI and ML pieces to it, right? This is where it differentiates. It's like the whole artificial intelligence is on another level with ML incorporated into it. So so machines in general are always told or programmed what to do. If you have a microwave oven, if you put it for 1 minute, it does the job for 1 minute. That's all it does. But in the world of machine learning, the program is built to grow. It's built to acquire knowledge, store it, and act upon it. Very important, all these terms. So let's say you the same microwave oven case. You put in food again. Let's say you are putting in food for the fourth time or the fifth time in a microwave oven. What if the microwave oven pops up a message says, "Hey, this is the fourth time you're heating food for the day. Do you really want to eat that?" No, no, something like that. So it's like imagining cases like that will make you understand what machine learning is, and what traditional programming is in a simplistic way. Right, another simple use case, a real not simple use case, a real world example. It's a Siri of iPhone, which is now practically running all of Apple's AI. It's all started with Siri. How Siri was in 2010 and how Siri was in 2014. And so it's a big difference actually, even though it was not very clearly evident for most people. What we mean by that difference is that when Siri was introduced, was a very finite set of corpus. When we say finite, it's for Apple's case, it's a huge corpus of data. In terms of language structure, language semantics, and language understanding, they had a whole thing that Siri would act upon. It's all within your phone. Um, s- Virtual assistant, NLP, natural language processing and understanding, but it was a finite set. When in 2014 Apple adopted deep learning, we'll see what it is, and we'll see how it started using that and making subtle changes from the user perspective, but it's grand behind the scenes. It started to learn from the data sets that people are giving, like the messages that you're talking to your phone is all collected, it's all acted upon, it's built as a whole growing neural network. Um, so now it started to understand your commands, understand the context better when ML was introduced, because now it is growing and it's not restricted to a finite set. So it started understanding dialects, it started understanding different tones, it started understanding different contexts, and thereby the recognition and the recommendations became stronger and sharper with ML induced in it. And after that, the whole landscape of Apple's AI with ML changed, and it's pretty much in every single product of theirs in Apple TVs and whatever that has come since 2014. It's influenced by that. All right, so that's a definition. Oh, actually, before that, I should have started the interactive questionnaire, but I think we're not too late. Before we jump on to types of machine learning, I want you all to try out an application where we would start interacting more in the form of question and answers. So you see right at the top of my screen, menti.com. If you all can go to that, you can go on your phones or on your laptops and type in the code 3361732. I can type in that. You will see this on your YouTube chat. The code is 3361732. And if you all can hop onto that, we'll have a few questions, a few exercises, interesting ones that'll explain concepts better with hands on. All right, you could start. So the first question that I have on screen is, what's your knowledge level in AI and ML? We'll wait for more participants to join in. If you have any difficulty in accessing the application, please shoot out a comment on the chat. We have a lot of questions planned on this one throughout the session, so it'll be interesting, I promise you. So you guys can hop onto this one. Yeah, I'll wait for 30 more seconds and then I will switch on. This will always be open throughout the session. You can join in any time and you can keep answering the questions as you go along. All right, keep going with the answers. Just in the interest of time, I will go forward and get to the next part of the presentation. Right, so what we are going to see is different types of machine learning. So we're going to talk about three different types, right? Three different major types of ML techniques. One is what is called as supervised learning. The second one is unsupervised learning, and the third one is reinforcement learning. So it is always better understood when we try this out and do a bit of an exercise. So that's where the Mentimeter thing comes in. So again, switch back here, and I will move on to the next part of the question. Right, type in the next question that you see on the screen is what's your profession? Like whatever you, if you're a student or someone in the IT industry, or it could be anything. Just type in. So just to get an idea of who's in the play here. Thank you. All right. Okay, I'll move forward. Right, let's do a simple exercise here before we go and explain the concepts. So you see a question in here, right? Very simple. A function of 1 is 1, a function of 2 is 8, function of 3 is 27. What is function of 4? Nothing fancy here, just a simple set of questions. If you're on your phone or on your laptop, you should see 4 options. Yeah, I see the answers coming in. So anyone who's coming in, you can always hop on. You don't have to start from the first. You can always start from wherever you are. Like this is the third question. You can start answering the question right from wherever you are. Yeah, it's better if you start to enter the answer. I mean, if you start to select the answers on Menti instead of typing it in on the YouTube chat. Cool. I'll leave this open for like another 30 seconds before moving to the next part. All these things might seem like, what is the point of doing this? But I promise you, at the end of it, it'll all make sense. All right, I'll go forward. The next one, you see a table at the first. Just focus on the first table. If it's not clear, you can zoom in, and try to answer what you perceive. Right? It's a table with 5 rows and 3 columns with certain information. Right? I'm not going to elaborate it because it'll just it'll just ruin the idea. So just go ahead and answer what you think. There's a column X, there's a column Y, and there is a column Z. Whatever you interpret, there is no wrong answers here. You can type in whatever you perceive out of this, and ignore the second table and the text at the bottom. We will come back to that. As I said, you can type in any answer. It's not. As I said, there's no wrong answers here. Whatever you perceive. Okay, I see one. All right. That's okay. I see a few more answers coming in. Right. Okay. Leave for another 10 more seconds and then we'll move on to the next. All right. I'll go forward. Okay. So next is a 10 set question. Again, it is not going to make sense when you look at it first. You may wonder, don't think too much. Just look at the pictures on the right and start putting them in some categories based on what you understand. Look the pictures closely though, and try to answer based on what you see, based on what you see further down the questions. You will understand this better as it goes along. So it'll be 10 sequential questions with images. I'll move forward. Right. So you see an image with that says, what is this? An image that says what a shape. You have to put it into one of these three buckets. Again, I'm not going to explain much because I'll ruin the concept, that'll ruin the idea. So I'll let you go free and try to bucket them in, and you'll see what this is all when you finish it. Yeah, I'll give like 30 seconds each for, I mean, or 20 seconds each for each of the questions. There's not a lot of answers coming in. It's very simple, guys. You can just hop on your phone and then just start clicking through the questions. You just enter in the code from your phone. You don't have to be on a laptop to do that. All right, I'll keep going. So, second question. You don't have to think too much. You can just, I mean, you can just look at the image and act on it as it goes along. So, all right. Okay, I'll keep going. Next one. Okay, I'll keep going. Next question. Fourth. So as you see, you can understand what's happening, right? As a new image starts to come in with each question, you are trying to figure it out what's going on with the type and the shape of the image. Anyone can join at any time. You don't have to be like, it's not like you have to be at the end. Anyone who's coming in new, you can just start picking up and from the fourth question start doing it. Yeah. Right. I'll keep going in the interest of time. The next question. The next one. Then the last set is here. Next one. The last three. Right. The last two. Last one. Oh no, one more. Sorry. I know it doesn't make any sense when you look at this, but now I'll just quick switch to the presentation. Then it'll all make sense. Yep. Got the answers. The very last one in the set. All right. I'll leave this last slide open so you can come back and start answering it anytime. Right now. Okay. So what you guys did now is three different sets of exercises, right? The first one, if I go back, the function of one, function of two, function of three, function of four, right? You had a set of inputs. You saw an output for that. Function of one is one. Function of two is eight. Function of three is 27, right? And then you answered function of four is 64. So it's a cube function. Now, what you did was basically identify what was the math behind that and answered for the answered for the outcome of the new one, right? That's pretty much what it is called a supervised learning. What we mean by that is you saw a few answers, you saw a few inputs, you saw the few answers, you determined what's going on, and then you applied that formula, applied that function on a new input, and identified it, and identify what's the result. So the known results are called as labels, and then the process of what you did is basically determining the output, right? So it is the definition goes like something like when you have a known set of values and you're trying to determine the formula and build out an output. It's kind of a machine learning model called as supervised learning. Now going to the second question where you had a table. Now let me open that. That makes it a little bit easier. So I'll keep going back previous question on the tables. Right. So this one. You guys started looking at the data and started entering it in, right? So what you're basically looking for is some kind of patterns in this, some kind of relationship between the rows. You're not looking for a specific answer. You're only trying to look at the data and understand what's going on and try to relate them, try to associate them, right? From a machine's perspective, if you look at it, for it, at least you can identify the context. Oh, this first row could be phone, the second row could be um, laptops, the third row could be your wearables. But for the machine, it's all new, it's brand new, right? The second table just tells like how it looks for a machine. It doesn't matter what it is. So I just put the first letters of each of those and write in here in these tables. That's how the machine is going to look at it. For it, I, the word I occurs three times in 5 rows. The word M occurs 3 times in 5 rows. And I and M together occurs 3 times in 5 rows. That means it must be significant. That means it must have a higher value or higher precedence over the others. So that's how it starts to relate things. And this is what is called as unsupervised learning. And we'll see a textbook definition of it as well. Right? You're learning something, but not based out of a past experience or a past value. You're making inferences. And then the next one where you started answering the questions, right, based on the images. So if you when you started it, you didn't have any clue what is going on, right? But as you go along, you would start to understand, oh, okay, these kind of dotted patterns fit in into quantis. These kind of blocked dark ones fit in into orbitals, stuff like that. You start to understand what is going on, and you're putting it in the right boxes as you go along the questions. You see, oh, okay, these blank empty ones goes into nucleus, stuff like that. You started interpreting it more and more based on what you are seeing, right? Oh, okay, this must be the right answer, and you're starting to make decisions. That is what is called as reinforcement learning, where you're starting to learn based on the results of your previous action and trying to course correct yourself as you go along. So you're basically seen hands on with all these three types of learnings. And that's pretty much what it happens in from a small scale to a large scale in terms of machine learning. Now we'll see some more examples as we go along this one. Supervised learning, as I said, known labels, right? So imagine, you all might have seen the cases where you go into a login screen, you're asked to pick, the cells where a particular car is there or a particular building is there. You start to tag pictures as a part of your login activity. You do that, right? So what basically is happening is all that images are being fed into an algorithm. That algorithm, builds a model, based on the known inputs, like to identify, it kind of makes an interpretation of how a car will look like in an image based on tons of images that you're feeding in. Now, when it is exposed to a CCTV video stretch, now it knows how to identify an image with a car and an image without a car. Let's say it has 100 hours of video. Now, for you to identify the parts where there is a car involved, or where there's, let's say, there's an yellow car, you want to find out an yellow car in that 100 hours of video. This algorithm will get you right there. You don't have to watch through the 100 hours of video, right? Because it knows how an yellow car looks like, because you tagged those images. So that's pretty much an example of supervised machine learning. Another example in there, right in the center of the slide there, to the machine, you feed in a bunch of labels, cats. You're saying, hey, these are the cats' images. Now start building a model, start building a mental image of it. The machine captures it, stores it, and builds a model. Step two, step one is that. Step two, now you feed in new input value. It could be images of cat, it could be images of dog, it could be images of anything. Now the machine knows how a cat looks like, so it will start to tag which is cat and which is not a cat. Very simple. So the first step is called as training. The second step is called as putting it into action, evaluating it. So it's this methodology is basically suited for two types of problems. One is classification, the other one is regression. Classification is trying to say a positive or a negative result, or yes or no kind of a scenario. When it comes to regression, it's about identifying values, right? What you did with f of 4 in the exercise. In here, you're doing like, it'll be like you're identifying a stock market value, or a dollar value, or you know it could be any numerical continuous number. This can also be used for to determine using supervised learning. Another example, you take 10 years worth of patients data, patients who have diabetes, and then you take 70% of the data, feed it to the algorithm. It tries to understand, oh, okay, these are the common patterns in the data, for all the patients with diabetes and without diabetes. And now you bring in a new patient's data. It tells you, oh, okay, this particular person, um, you know can have diabetes, and based on the data that it is fed in. So that's how you build a model. You build a model by feeding in information, by feeding in known values in the case of supervised learning, and then put it into test. Unsupervised learning, the second table, two things. You're trying to associate and you're trying to cluster. Associate means you're trying to find relationship between the values. You try to find out the relationship between iPhone and MacBook. You try to find out relationship between iPhone and Fitbit. You're trying to make uh, an inference of what it is like. Um, 60% of the people who own an iPhone also own a MacBook. The traditional example that we have. 60% of people who buy bread who also buy a jam, stuff like that. Again, the reason why it's called unsupervised learning is because we are not feeding known values. We are not feeding labels. We are only feeding data, and it identifies patterns in the data. Clustering, meaning you're trying to group the data based on its occurrence, and derive information out of that grouping. Let's say you feed in information about a lot of people's online platform watching, and then you find out that most of the people who watch Netflix are in the metros. Based on the geographical data, you can come to that kind of a conclusion. So you're starting to cluster stuff in based on the data that you're seeing. And the image at the center also shows that you're feeding in raw data. It starts to interpret. The model identifies, oh, okay, similarities in the data, and now it takes, okay, these things are similar. I'm going to group it like this. All the red ones are grouped, all the green ones are grouped, and all the purple ones are grouped. That's a kind of an unsupervised learning, and that's how a model in unsupervised learning is built based on similarities. Reinforcement learning, we already saw through the example, so I won't dive in deep into that. So, just in the interest of time, I just want to quickly go through one of the key learning methods Right, we all talked about machine learning types and differences. So how exactly does a machine capture this information, use this information, and take decisions? Right, you need to understand that part. That's where the crux of this. Right, you all might have been familiar with, I mean, different methods of learning that we have come across through our careers and lives across. In the world of machine learning, the most popular method is what is called as deep learning, and I'll try to quickly simplify it and summarize it with the two images in there. I'll focus on the first one. Basically, let's say there is an image of a car. Going back to the first example again, the way it is stored in deep learning, or neural networks, deep neural networks, is the image of a car is split into several layers. Let's say the first layer is focused on the car's exterior. The second layer is focused on the car's tires. The third layer is focused on the interiors, stuff like that. You split the image and you put the images as nodes in the layers. And then you start to connect the layers. Between each layer is a feature. The first layer is the exterior, the second layer is the tires, the third layer is interior, the fourth layer could be your front part, the logo, it could be anything, right? You start to feed in a lot of different car images into this model, and it starts to build this network. Obviously it's inspired by the neural networks of inside your brain, and it builds these connections between the nodes. And now when a new image comes in, like, if you want to interpret what that image is, it kind of runs through these nodes. Okay, so it will illuminate or it will excite certain nodes based on a match. If it finds a match, it will excite a node, and then the corresponding nodes in the second layer will be excited. Okay, this node is connected to n number of nodes in the second layer, and then those nodes are connected to another x number of nodes in the third layer. So likewise, it builds a model and tries to understand, okay, if it navigates through this path, then it's an Audi car. If it navigates through another path in that layer, then it's probably a Ford, something like that, right? So that is how it an image analytics is stored in a deep neural network. But it's not just restricted to images, it could be anything. Every layer could be a feature. Take diabetes, the first layer could be your age, the second layer could be your um, uh, you know your BMI, or could be third layer could be your historical um, disease factors that you come across, stuff like that, right? You can split your problem, put it into layers, connect the layers, feed in the new input data, you'll start understanding more. So that's one of the learning methods. I wouldn't dive deep in, just so in the interest of time. I'll switch quickly to the rest of the topics. So just a deviation from machine learning. We also heard about data sciences and AI in the same context, right? Trying to differentiate and show how it all looks together. Right. The diagram at the center shows where machine learning fits in the whole data science. Right. The whole thing here can be considered a data science. Computer science, a big piece of it. Maths and statistics, that is a huge piece of data science. And then subject matter expertise, depending on the field where you're applying data science, subject matter expertise is also a key area. Now, where does machine learning come in? It's where the computer science and the maths and statistics overlap. That's just the machine learning piece. And when you bring in the subject matter expertise also into the mix, that's where you get that unicorn, where all the different pieces come together, and you're trying to be trying to leverage each of the pieces to solve your problem, from computer science, maths, and subject matter expertise. And now our focus is primarily on machine learning, just to show where it all fits in. Right. Another view of all that we have seen, artificial intelligence is the whole big bucket. Machine learning is inside it, it's a subset. It's what makes artificial intelligence happen. But it's also important to understand that there is artificial intelligence without machine learning, the LO part in there. That is also a key thing to understand. And then within machine learning, one of the methods is deep learning. So putting it in words, the intelligence or the artificial intelligence is acquired and developed by learning. Learning is achieved through learning methods, which is deep learning, one of the methods. And the learning methods are always built on the raw data that you feed in. Data makes AI better. The more data you have, the better will be the learning. The AI makes machines better. Better the decisions that you're taking with better the decisions that you're taking, the more useful machines will be, right? If it starts giving useful information, you'll start getting more, start making the machines more useful. Some of the real world examples, you all are basically using machine learning in different forms and different factors across your everyday. Um, but to categorize it into areas, it kind of falls into these ones: image analytics, virtual assistants, predictive analysis, machine learning, that all that we saw about now, natural language processing, self-driving technologies, and robotics. So the key thing to understand here is the centerpiece, the machine learning, can be applied across all the other six areas, and you can basically put that on basically supercharging these techniques with machine learning across these six areas. So never look at AI just in the context of all the other things. Always look at it with machine learning. It's a whole new perspective. So some of the examples I've listed in here, I just want it's on the screen, so I really don't want to take too much time talking through it. But just on the core MLPs, um, some of the areas, anything that's regression that we talked about, price predictions and forecasting or regressions, patient diagnostics and drug discovery, or more like the classification areas, classification and even clustering areas, recommendations engine, association area, fraud detection, it could be classification again. Those are all the different areas in the core ML, just the ML piece itself. Right. So I've got like 10 minutes. So I'll just quickly go through the software ecosystem involved in machine learning. Um, I'm just double checking. Uh, I have about 7 minutes, right, Kritik?
Yes, Mr. Logesh.
Yeah. Okay. Thanks. All right. So, what are all the some of the platforms and languages in the ecosystem of machine learning, and what is there's plenty, obviously. Now, I'm just focusing on some of the key players, topmost players in the area. In terms of platforms where you can build these models, you feed in this data, you build a model, and you put the model to test, and you take it to production. Some of the key players in that area is Microsoft's Azure ML Studio and AWS's SageMaker. There are plenty. There is Google GCP platform for AI as well. There are a lot other more things, but these are all kind of the front runners. In terms of languages, Python and R are predominantly the leading languages. They have frameworks, they have libraries built in for machine learning. The next interesting one is services. It's slightly different from the platforms because these ones are like yours, like more like a subscription service. If you want an image recognition service, if you want a recommendation engine, or if you want speech analytics engine, you can pay for those services and use those with your applications. And Amazon Web Services is kind of leading in that area. It's got not hundreds. It's got tons of services that you can just start using it and plugging into your applications. Salesforce Einstein is a Salesforce is a cloud platform that offers this Einstein recommendation engine, a brilliant model that is scalable as well. Those are all services that you pay for and get benefits. Frameworks, you never start from scratch these days. You always have a framework to play with. And some of the famous, popular frameworks in the machine learning world are Apache's Spark ML, TensorFlow, and PyTorch. TensorFlow from Google and PyTorch from Facebook. Certifications, some core areas. There isn't a lot, but there are some very good ones. when you want to take deep dive into ML, and you can start right from the scratch and then scale up in all of these areas. There's one by Stanford, one by IBM, there's one by AWS, and also there's one by Salesforce. Now, what's trending? I will stop with this one and the next one, the last two slides. Auto ML and teachable machine and tiny ML, three concepts that are kind of in the play recently. It's seeing a great progression in these days. Auto ML, what it means is, to put it simple, and we've all seen the movie where, it's just an analogy in Robo where robots make other robots, right? One single robot makes another robot. It's similar, analytically, not exact, but it's just an example. When an ML, we have an ML model that generates another ML models, another sets of ML models. That's what is called as auto ML. Because for large corporations, you cannot think about creating MLs for every single customer, right? Amazon Web Services is going to have hundreds, thousands of customers. They cannot build a machine learning model for everybody. So they have a machine learning model that builds these models. So that's the next level, right? It's meta in terms of how it works. And Salesforce Einstein is a prime example of how that works. Teachable machine, it's a cool one, cool application. You can check it out at teachablemachine.withgoogle.com. You can feed in your images for the machine to understand. Right, you start to feed in images of your phone, different ways it looks like. Now it can interpret your phone, stuff like that. You can feed in text. You can start pronouncing words, and it grasps that and it generates a model, and you can use that right away. Tiny ML, taking the machine learning model and putting it into microcontrollers. It's another level. I don't want to go in deep in detail towards that, but it's starting to get traction, and you should definitely look at Solar Scare Mosquito Project, a very interesting use of how a machine learning model has helped detect mosquitoes and prevent mosquito breeding. You'll see how a machine learning model runs in microcontrollers. All right. I think I'll skip this. It's just Gartner's Magic Quadrant for ML platforms and AI services. Put it on the screen. I won't talk through this just in the interest of time. Last, last but not the least, definitely. So I know everyone is kind of getting into ML, but how do they start? How do they navigate this path? The key thing is to keep an eye on the problems that are solved by ML. Just start listening to it, start looking for it, and try to have a visualization and ideas repository of the problems that are solved by ML. That'll help you when you come across an interesting challenge in your career. So now you think that, okay, so these things can be solved by ML. That's how you generally get started. You cannot force ML into anything. You would start looking at patterns, start looking at problems, and you will figure out where ML fits in. So a lot of knowledge in terms of acquiring that is needed. Another thing is you are never starting on zero. So that's something people uh, don't really recognize. Your skill sets, whatever you have, is very essential. It's very valuable when it comes to learning ML. It could be anything. It could be any area, any technology that you've had exposure will have a meaning when you take up ML. That's a important thing. But you should also make sure that you're aligning your skill set. That would make a very big difference, right? You have knowledge in an area, but you have to start thinking in terms of ML to make an impact. And how do you build? How do you start building it? Always find use cases, smaller use cases, simpler use cases to solve, and then build on top of that. You cannot take a huge monumental problem and start. That'll not be the way to go. Look for smaller problems, look for similar solutions, and then start building them one by one. It does not have to be complex. ML problems do not have to start complex at all. So that's it. I'm done. I just want to take a few seconds to show what we generally do as a company. As I talked about, we Kaneeni.com is acquired by Human. Human is a US based company. These are all the three areas that we focus on: business consulting, cloud implementations, and technology training. Uh, and technology training is what we are currently talked about in terms of machine learning and Salesforce are the two areas that we focus on, with more focus areas coming very soon. That's all I had. Kritik, over to you. If you guys have any questions, you can type in. We're happy to answer them.
Yes, sir. So it was a great session, sir. And audience, if you have any questions, do drop your questions down in the YouTube chat. It'll be answered by our resource person. We'll wait for 1 more minute for questions because it's already 1 hour. It's crossed 1 hour. A stream.
And it's also, if you're all still on the menti.com, I just opened up the last slide where you can type in, give in your comments in 2 words or 2 or 3 words in your about today's sessions. It's on the same page as well. You can type in your questions also on the YouTube chat as well as on the menti.com, wherever.
So let's move on, Dr. Shanti, please. You have, can you please unmute yourself?
Yeah, it's Lokesh. It's a very excellent session. It's eye-opening session. Those who are beginners, what's meant by AI and ML and data science, everything you have been explaining very clearly, detailing. Yeah, it's a time for a vote of thanks. Ladies and gentlemen, a warm and pleasant evening to all. At the outset, it gives me an immense pleasure to propose the vote of thanks for this wonderful occasion, an international webinar on an interactive intro to AI ML. I would like to thank today's young and dynamic resource person, Mr. Lokesh V, application architect, founder Kaneeni, USA, who honored this program despite its busy schedule, has found time to grace us with his wonderful lecture. Thank you very much, Lokesh.
Sure. Thank you very much.
Yeah. I'm also very grateful to Thickness Learning community, young and dynamic founder Mr. Kritik Raja, and members of TLC for their encouragement, backing, arrangement, valuable contribution, and wonderful support to make this webinar grand success. Last but not the least, I would like to thank all Thickness Learning community beloved participants from different positions for showing their interest in this webinar, for making this event as a resounding success. Thickness Learning community upcoming courses are IELTS, Artificial Intelligence for Everyone, Functional Mathematics, ESOL, etc. Upcoming free webinars are Green Chemistry and its application in sustainable living, Python programming, basic electronics, etc. Once again, I thank one and all present here. Have a wonderful weekend. Thank you very much.